Okay, so I know you're already all sick of my voice, which is why I'm now going to be talking to you the next 30 minutes, so you're stuck with me. My name's Drake, and I will be covering a much more boring talk, which is just database options on Azure. Because as was mentioned before, there's a lot of options, so you might need some help. I know I did. So I'm a senior software engineer with Rogue Fitness, and I do a lot of work with cloud modernization and cloud migrations and app modernizations in AWS and Azure. Although obviously I'm more Azure focused, and couple certifications out of the pile are all Azure focused. This presentation exists because databases are really important. You will not have any of our modern apps without them, and because there are too many options to know how to select. So the goal of this presentation is to give you a framework for how to make decisions about databases. It's going to be a simplified one. It's a bit more of an introduction, but this will at least get you thinking in the right terms, talking the right language for making selections. And then I will cover how to configure a free database on Azure for personal projects because, yeah, you need a free database for your personal projects. I have lots of stories. So first question, what is a database? A database is a structured set of data held in a computer, especially one accessible in various ways. So does that mean that a folder full of PowerPoints is a database? Maybe. It's debatable. It's a little bit of a weird definition, but mostly we'll be talking about more standard databases. And then the obvious next question is, how do we evaluate if a database is the right solution for a situation? And here's where we talk about non-functional requirements, NFRs. So people know about functional requirements. A functional requirement is, does a unit, does a service, does it perform the intended purpose? So let's say I had a water filter, and the functional requirement is it takes ocean water and makes it drinkable for humans, makes it potable water. So, okay, you're a customer, you're down in Florida after a hurricane, you want to buy a water filter to filter ocean water. So you're like, oh, I need a filter to filter water, make it clean and drinkable. Great, here's the filter. It filters 1 gallon a week. It costs $2 million, and it won't be there for 5 years, but it filters the water great. It's like, that doesn't meet any of my requirements. This is garbage. I don't care that it filters really well. It costs $1 million, and it won't even be there until I'm already dead of dehydration. So functional requirements are what it does. Non-functional requirements are what it is. This is a common list of non-functional requirements. There are various lists, but things like extensibility. How easy is it to add new features to software, to databases? Availability. Even if your app's really good, is it always available? This will vary because all these things are trade-offs also, very important. You can have an app that's easier to add more things to, but then it becomes less reliable. Scalability. Maybe you have an app that works really well for 10 people, but wouldn't function for 5 million. Then, I don't know, Facebook wouldn't buy it. Maybe the Bat computer is really solid for 1 Batman, but what if there were 10 Batman and it just stopped working? Reliability, similar thing. Maintainability, how long can it last? How well can it function over time? There's probably some really great databases that aren't really used anymore. Security, a lot of them actually are really obvious. I'm not going to go into detail for all of them. Testability, deployability, reusability, readability, configurability, and performance. So just know that these are all trade-offs, and these are not necessarily, does the software do the thing? Like, I don't know, does this software translate English to Spanish? It could translate well, but it's totally insecure, or it's crazy, or it's very reliable. These are separate from the actual functionality in some ways. And there are a bunch of different standards. There is not a standard list of the NFRs you need to know. This is, I forget what this is from. I think it's from one of the Azure frameworks. I don't remember which one. But like reliability, security, optimization, operational ops, excellence, and performance efficiency. And the biggest one in my mind for NFRs overall, it's always about the money. It doesn't matter how good it works if it costs too much money. And especially this is important because any database can do anything. Lots of scare quotes. Because you could have, I don't know, a SQL database, and you use it to store, let's say, PowerPoints and Kindle book files in a SQL database. Will that technically work? Yes. Do you want to do it? Probably not. But if you're willing to pay enough money for a powerful SQL database, that technically works. There's a bunch of weird things you can do. So it's really, how do we get to use the most efficient database for a solution based on like what is efficiency? Is efficiency security? Is it reliability? Is it cost? So that's the big thing to think about. It's not, oh, can this database do what I want? It probably can. It's, can it do it well? Can it meet my other requirements? So there's a lot of different types of database structures. That's the first thing we're going to talk about, is do I want a structured, semi-structured, or unstructured database? A structured one, think SQL, think relational databases. A semi-structured are a lot of varieties of NoSQL databases, such as document, graphical, keyvar, blob, keyvar, and others. Key value pair. I don't know if it's keyvar. Key value pair and others. And then an unstructured one would be more like blob storage, just pretty much no structure going on. I'll go into these in a bit more depth. A SQL database, who here is familiar with SQL databases? Yeah, vast majority, very common. They're so common that that all other types of databases are called NoSQL, which I mean, like, that's impressive. Like, that's how you know you've made it. It's like, imagine if I could say, like, I don't know, I work for Rebel Fitness, well, I should be starting soon. So if I could say there's Rebel Fitness equipment and then there's other non-Rebel Fitness equipment, that would be an achievement. It has rows and columns, and the rows all have the same columns. There's a schema on write, so when you're trying to insert data, it validates that it's the right type. And it's really reliable. There's a lot of reusable benefits, but it's a pain to deploy. You have to do a bunch of configuration changes if you want to change a single column. If I want to change it from, I don't know, an int to a long, it can be a nightmare. Just even changing single columns or adding some and doing updates. But, so variety of benefits, variety of drawbacks, as well as scalability. It doesn't scale well horizontally. We'll get more into that later, maybe. And yes, SQL, the query language, is not the same as the database. Just throwing that out there. They're related, they're not the same thing. You can actually use SQL query language to query non-SQL databases. Not confusing at all. Document databases. This is one of the more common forms of NoSQL databases, which is essentially there is a key and then there is a JSON of some shape. The benefit of this is it has some structure. You can search based off of the various keys and values inside of the JSON, but also you can insert kind of whatever you want. So it's really easy to configure. If we're working with a fast-changing company and they want to start, I don't know, measuring favorite color for their customers, they can do that, add it in, no extra configuration work. And then, especially in Azure, they are very deployable, very scalable. We'll get back to that later with Cosmos. But if you're trying to do complex queries between different types of data, complex searches, it costs more than a SQL database would. Some of that complex, interconnected stuff, it can do it, but once again, you pay for that either in speed and reliability and cost. And then graph databases, I'm trying to pick just a few of like different types. This is a database specifically made for capturing relationships. So you'd have nodes, like, I don't know, let's say Mark and myself, are both on LinkedIn. If you didn't know this, people are on LinkedIn. I assume none of you are in the room. It's a very new thing, and no software developers use it ever. My sarcasm is great. But nodes are the individuals, and edges are the relationships. So somebody likes a post, somebody comments, somebody owns things. This captures specifically highly interconnected data sets. For example, if you wanted to do searches of what's connected to what to do something like a Facebook marketing campaign, this is way more efficient than a SQL or a document database for that kind of solution. So it's great at relationships. It is garbage at everything else. It is a very specialized database. And this is just a sampling to show you the kind of different things are out there and how they are specialized for different uses. There are a lot more NoSQL databases. I got 30 minutes. So just be aware, there are too many to go over, and there are more and more niche ones that solve certain problems very well. So next we come to database management. So first was the structure of the database. Next is how we actually manage it from an infrastructure side. To badly oversimplify, so is everybody here familiar with infrastructure as code platform or infrastructure as a service, platform as a service, software as a service?
With software as a service.
Okay. I'm not seeing a ton of enthusiasm, so I'll cover them a little bit. Infrastructure as a service is if you set all the configurations yourself. Azure gives you a pretty much blank compute resource, an empty VM, and you have to set what operating system is on it, you have to do all your downloads, everything is kind of set up from scratch, which gives you a lot of customizability, but it is a nightmare to configure. This one spent like 2 weeks trying to configure a virtual machine scale set to be a, what was it? It was a running agent for Azure deployments. Ugh. Stories. None of them are good. I didn't succeed after 2 weeks. Moving on. Platform as a service is Azure does part of the work for you, but not all of it. So think a web app. So Azure sets it up so that it can run I don't know, let's say JavaScript, it does all the downloads for you, but you still have some configuration. You're actually writing your own code to run in there. And then software as a service, that is something like Gmail. You don't touch any code, it is fully set up for you. You don't really see software as a service for databases. There is Azure Dataverse, Microsoft Data, yeah, Azure Dataverse, which is part of their low-code platform. If you have questions about that, ask afterwards. Would not recommend. Not a big fan. It can't do complex queries. Different story. But so we're just going to talk about infrastructure service and platform as a service. So infrastructure service, configurable. It's very commonly used for lift and shift because if you have a fragile legacy application, you can put in exactly your previous settings into the cloud. Just drop them in. Super easy, no changes. However, if you're making a cloud native application, making a new application, you're going to go for the platform as a service options 9 times out of 10 because they often have massive cost reductions. They have things like updates and security partially managed by Azure, which takes a lot of load off you. You don't need to, I don't know, if you forget to run a new patch, that can be very bad. Azure handles that for you. And then they also allow a lot of scaling options, other benefits where it takes a load off your shoulders. Generally, when you can, a platform as a service option is preferred. I say generally because it depends is the motto of all software developers. So now let's look at what those actually look like as options on Azure. So relational databases. You have the SQL database service. That is PaaS. You just click go and it makes a SQL database for you, handles things under the hood. Infrastructure as a service would be a virtual machine running SQL. You can even just have a regular virtual machine, or you can have a SQL virtual machine, which is partially configured for you, because there's actually a lot of things that are wiggle room in the middle. For example, a SQL managed instance is kind of in between because it's still mostly configurable, but Azure has done a couple of the basic steps to make it more optimal to run SQL. So there is, we say platform as a service, infrastructure as a service. It's actually a massive gray area, which contains other things like, I don't know, containers as a service, other things like that. And then also it is worth mentioning, since somebody made the AWS versus Azure question earlier, it is nice to run SQL on Azure because Azure owns SQL, so they have discounts on licenses, but there are certain kind of things that you prefer to run on AWS, like video streaming. But for SQL databases specifically, Azure has some cost benefits generally. For no SQL databases in Azure, there are technically multiple options. Obviously, if you run a virtual machine, you can put anything on it. Like it's a computer. You can run whatever database you want on your computer locally. You can run it on an infrastructure service. But if we're talking about platform as a service on Azure, it's Cosmos. Technically, you could use, I don't know, like Redis Cache is a platform as a service database, a couple other options, but it's going to be Cosmos most of the time. And Cosmos is really cool because it has different API setups that use different types of databases. So the NoSQL one is a document database. The Cassandra is a wide column. The tables of value pair. Apache Gremlin is a graph database. So these are actually different kinds of databases all under the hoods of Cosmos. The benefit of being on Cosmos is that it's very easily scalable by default. There's a bunch of cost benefits, and it's also globally available. So if you're working with Platform as a Service, Cosmos is pretty common for new projects. Then, so we've covered structure of database, and then we covered management. Next, it comes to cost. There's a lot here. So I'm going to cover the bare basics, which is capacity and pricing. There are provisioned or serverless options on Azure. A serverless option means the database only starts up when you trigger it, so it can go to sleep and save you money the rest of the time. This can be a really good option for some like personal projects or smaller things where you're trying to just save as much as you can, or for loads that only run part of the time. But provisioned is usually more efficient if you have a consistent throughput. And provisioned is saying, we have this amount of compute available for the database all the time, and same with this amount of total memory. And there are a bunch of different tiers, and you can see this is just in the standard tier for SQL databases. There is a 300 times difference between the least and most expensive options. So there is a lot of issues of how good a database do you want? How fast does it have to respond? How complex are the queries? Because this is where the question of saving money versus performance versus speed comes into play. And then service tiers as well. There is standard, there's basic, there's premium, other things there, and also some various other configurations, especially in Cosmos. You can configure something to be more reliable or faster. There's actually a way to configure that. Like I said, not going to get into all of it. Just be aware these are the kinds of trade-offs you're making, and with cost being another big factor. And beyond that, there's often auto-scaling abilities available, especially for Platform as a Service options. You can technically do it for some of the infrastructure as a code option if you set up scale sets, but it'd be a lot easier to scale with the Platform as a Service options because they have that built into the service. Yeah, I think that's everything there. Yeah, go for it.
So if I was a student and I wanted to play around with the SQL database, would you recommend DTUs or vCores?
I think that if you're going for the absolute cheapest option, I believe DTUs have a cheaper option, and I believe they also have a serverless configuration. So I set that up for a personal project once for a silent auction thing I was making that it got somewhere, we didn't get it very far, and I think that I was spending maybe 30 cents a month because most of the time I was asleep. Sure, it was a pain to use because the first time I'd run the app, it would take like a minute to start, and then if you stop using it for more than 30 minutes, it shuts off, but also 30 cents a month, and yeah, totally worth it to get the cheaper option.
Conversely, I had a student who did the cheapest vCores, and he got a $200 bill at the end of the month.
Yeah. Oh, big thing to remember with Azure in general. Azure is, they're not selling you products, they're selling you services. Like, let's say you were buying gasoline from a gas station. That gas, you then drive with it, it gets used up. If you drove around and used up all the gas and then asked for a refund, would you get it? No, because you used up the gas. If you ate food and then tried to get a refund, would you get it? No, because you ate the food. You're actually using up the service. So if you spend a lot of money on Azure, you do not generally get a refund. It can happen. I've heard of it happening, but just be very aware. $6 per hour is a lot because there's a lot of hours in the month and there's a lot of hours in the weekend when you start running things on Friday and you're really tired, and all of a sudden your app gateway ran for the whole weekend and it spent $50, which I'm not going to say happened to me, but it's happened to me twice. My company had like free Azure credits at the time, so you get like $50 a month, and people ran out their 50 and then they're like, well, I guess I'm done learning for the rest of the month. Fun stories. But yeah, so that's important. Which brings us to free databases, which is how you get around this, which is use Cosmos. Cosmos has a really great thing where it will do provision throughput, where the first 1,000 request units per second and 25 gigs of storage is free. You can only have one per Azure account, but that's a lot of compute power. That is a lot of memory. There is a website, or there's an email forwarding application I built for a North American volunteer group across all North America, and it runs entirely on one free tier of Cosmos. So that's a fair bit of memory, and you can set up different containers, so you can have 10 different apps using different containers on the same Cosmos database. So if you want to play around, free. Best price in the book. So I read lots of books and learn. Like I said, I can check my time real fast to make sure I'm still good. Let me see. Took a picture of the schedule, and perfect. I'm right on time. So I read literature on learning a lot because I am a nerd. If you want recommendations, Make It Stick is the one I just reread recently. Very good. And one of the things they teach you is if you want people to remember things, you have to get them to generate stuff themselves. For example, by practice test. How do you find out what the NFTs for a project are? And I will wait until somebody has an answer. The non-functional, NFR. Oh. Non-functional requirement. Oops, that's I might have added this slide a little bit later and then I didn't proofread it. Okay, NFRs. See, I was checking to make sure you're listening. Okay.
Was that intentional?
No, I wish. That'd be way smarter if it was intentional. Who would like to answer, how do you find out what the NFRs for requirement are? And I don't expect you to have good answers. I want mediocre answers only.
Well, of course, I'm going to give you a mediocre answer then. So you find out what the project is, or you figure out what the project is.
But isn't that the functional requirements?
Well, isn't that what it does, though?
Okay, yeah, that's fair. Okay. I probably should make somebody else run the mic.
Oh. I'll just pass this on to the next person who answers.
Yeah.
Thank you so much, Drake. Great presentation. I will say it is to conduct a full analysis of the one of the use cases and then get rid of all the functional requirements, and then you have the non-functional requirements.
See, that would be a great answer. I wish our customers had answers like that because, so asking, that's great. Like you said, I know you ask like, hey, what is your budget? How do those things work? But the real answer is iteration, so trying it multiple times, and then eventually with great difficulty, and the NFRs will eventually find you because the NFRs are what make customers like call you on your personal phone at like 8 p.m. because, well, the website's down or we need to refactor things from scratch because people often don't actually think about their NFRs. So the reason why I'm talking about them over and over again is people think a lot about their functional requirements. They don't think about the non-functional requirements. I mean, anybody here that's a more senior developer, how many times have you suffered because a customer had to have an entire thing rewritten from scratch because you set up the architecture for a different set of functional requirements? Yeah, 4 times he's had to rewrite it entirely from scratch because the hard part about NFRs, code doesn't fix them because they are fundamental to the architecture of the project often, not always. So fair warning. Next one, easier question. A client has legacy relational database in 2006 with custom configurations. They want to start migrating to the cloud, but keep systems stable. What Azure database service should they use?
It's a relational database using Cosmos.
Go with the...
Takers, just raise your hands.
Yeah, just...
What if they just use MongoDB?
Okay, I actually haven't used Mongo yet much.
That was actually one of my questions I was going to ask is like, outside of just being like
You're good.
the sales of Azure is like, why can't I just use like MongoDB or just like any other free open source service?
I mean, they're not free? At some point you have to store data or pay for compute.
Yep.
Fair enough.
Plus you have to like probably like pay for like the server to stay up in general.
Yeah.
What if you have your own
But-
server?
Then,
At
well,
your
that...
house?
Yeah.
Yeah, no, if you can have on-premises servers, that's, but that's the whole question about switching to the cloud or not in general, which is the cloud means somebody else provides the security, the data is replicated in multiple locations, cost savings based off of lifetime electricity and warehouse things. It's not always the case. Sometimes on-prem makes more sense, but it doesn't always.
Oh, so Drake, in this case, you wouldn't use any Azure managed database. You just rent a compute engine and configure exactly how it was.
So you're saying essentially put it on just a VM that you set up totally from scratch?
Yes.
Okay. That is an answer. The thing is, there's a lot of answers. They're not all good, but there's a lot of answers. Okay.
So it depends on how much effort you want to put into this process. If you're doing just a straight lift and shift, as you said, sticking it on Cosmos DB or Cosmos for SQL would probably be fine.
Cosmos doesn't have a SQL.
I'm sorry, SQL database. Yeah, it does have
Yeah.
SQL DB. Yeah, so it'd probably be SQL DB, or just like Kemming said on a compute instance, just so you can lift and shift. But for something more advanced, you might want to consider platform as a service, which I did believe you mentioned as well, for one more of a cloud native re-architecting.
Yeah. So that's kind of where I was getting through with this. I'll give you the next one, first shot. Or do you want to?
My answer would be an Azure managed instance here.
Okay, yeah. So this is something where if you want to have fully custom configurations, especially for an older thing, platform as a service won't work because Azure has a limit to how far back their platform as a service options go. They just won't let you have a database configuration more than how many years old now? Do you have a ballpark?
I don't know. But,
Okay.
To add some color to the SQLMI comment, if you're using SSIS or SSAS or SSRS, I feel bad for you, but those are a thing, and those are usually the things that are not supported in SQL database, which is the PaaS offering. So those of you SQL database admins in the crowd, you know what I'm talking about. So.
But yeah, so often, you're exactly right. You put it on a VM or a SQL specialty VM of some kind. So last question, easy one. Client is a startup making cloud native applications. They want to be able to iterate and expand quickly. What Azure database service should they use?
Anybody?
Yeah.
Cosmo.
Yes, Cosmos. That's the easy
But
one.
which version of Cosmos? Because Cosmos has multiple
Ask the
APIs.
client more detail, because that's the other answer is these do not tell you anywhere near enough to actually answer things. This is a massively oversimplified version. The real answer is if a customer tells you this, lock them in a room for a 2-hour interview until you figure out what they really want, because something's missing. You've been there. Okay. Yeah, or even sometimes with consulting firms will even have a 2-week investigation period or build the first version to do things. But that is it. Thank you so much for coming. I'm really happy that okay. There we go. Yeah, really happy that the first one of these in a while is going well. I have a summary slide, so if you have any questions, fire away. We have 5 minutes.
I don't need a microphone. This is just kind of a housekeeping thing. Are any of these slides or all of them be available?
That's a good question. Hey, speakers, would you mind sending me your slides after this? Okay. Perfect. We will make them available through Google Drive link probably or something like that with all the slides in it.
OneDrive link? Come on, man.
Okay. Sorry.
Matt was
we
staying
will
on
make things
brand.
available on a blob storage account with public access.
Stay on brand.
Sorry,
Come
I'm
on.
going to set up an Azure function. I'm just going to send out the API URL to the Azure function to download this.
What is the blob storage again?
Oh, so blob storage is essentially if you want to, binary large object.
That's it. Yep.
Isn't there another beat? Blob?
Object
Okay.
has a B in it.
Oh, yeah,
after
okay.
the O.
So essentially, if you want to store any random type of file, like let's say you want to store a PowerPoint or a movie or something else, that says you can stick any large file in it. Technically, you can take an entire SQL database and store it in blob storage. Which is why this all gets weird, because everything kind of interacts in that way. But generally, it is how you store large individual files or random types of files.
There is some, like, if you want to go super cheap and store stuff on Azure, the Azure storage accounts have 3 modes that they can be used in: blob, table, which he mentioned in Cosmos that there is table support in Cosmos.
There's a second table thing also.
But you can do in blob storage, or in a storage account, you can do tables, and you get rows and columns and things like that, and then it's super dirt cheap. So, and then there's also queue storage. So if you need like like RabbitMQ, but you don't want to pay for a RabbitMQ server, or you don't have a RabbitMQ server in your garage, like that guy right there, you can use Azure Storage Account, and it's super cheap. So.
Okay, I think there were a couple more questions.
Oh man.
And then thanks again, Drake. Really quick question. So when you have multiple clients, multiple companies, and then you're using the same non-SQL database, what are the security concerns?
I would not do that. Like that would never ever happen. I'm more saying, so for the volunteer organization that we did this for, we actually made them their own Azure account, and they have the free tier database on their Azure account. For my personal projects, where I don't care about security because nothing I write is worth anything, there I will put multiple things in one database because I'm just messing around with it. So that's like, I would more put multiple things inside of that, either within the same company, different things within one container, one documents account, maybe, depending on how the company works, depending on security procedures and kind of what applications are, or just for personal use, the way the free database is set up. If you want to stretch your free database as far as possible, you can share multiple things on different containers in the same one. I would not recommend sharing multiple clients' things on the same database, essentially ever.
Unless you're building like a multi-tenant SaaS.
Yeah, like there's a couple
then
situations
that's
where it
a
could
whole
happen,
different ball of wax.
but almost never. Just
Yeah.
pretend never, and you'll be close enough. Yeah. Other questions? Probably last one, if any. Sweet, you all want pizza. So then I will let you go. Cooper, is the pizza outside? Pizza's outside. Be free.